Hello students, in this video we are going to discuss some more problems on formation of PDE by eliminating arbitrary functions. Okay, now it's a continuation of the previous video. So it's a 12th problem of this concept, and the first problem of this video is given by like this: form the PDE by eliminating the arbitrary function from z is equal to x into f of y by x plus y into phi of x. Take the given equation as number 1. Differentiating partially with respect to x, will get dou z by dou x is nothing but p x into, apply the product rule. Okay, first function x as it is, differentiation of f is f dash, y is a constant, differentiation of 1 by x is minus 1 by x square, plus second function f of y by x as it is, into differentiation of x is 1, y is a constant, phi becomes phi dash. Now differentiating one partially with respect to y, we get q is equal to x into f dash of y by x. Okay, x is a constant. Okay, keep 1 by x as a constant and y is equal to 1, and differentiation of y is 1, phi of x is a constant, keep it as it is, and here x and x get cancels, we'll get q is equal to f dash of y by x plus phi of x. Now differentiating equation number 3 partially with respect to x. Usually we are doing equation number 2 partially with respect to y to get the mixed partial derivatives. Since the number of terms are more, so I will go with another method, that is differentiating 3 with respect to x. Again we'll get a mixed partial derivatives. Both the ways are same, that is you can able to use any of the method. Okay, I will use this one. Differentiating of f dash is becomes f double dash of y by x. Y is a constant and 1 by x becomes minus 1 by x square, and phi becomes phi dash of x. Next, differentiating equation number 3 partially with respect to y, will get dou square z by dou y square is nothing but t, that is f double dash of y by x into 1 by x. Call that as equation number 5. Now multiplying equation number 1 with by x and equation number 2 by y and add together, will get px plus qy is equal to minus y into f dash plus x into f dash plus xy into phi dash plus y into f dash plus y into phi of x. Okay, observe here, this particular term get cancels, and observe these two terms, this one and this one, it's nothing but a given equation z. Okay, I will call the second and last term as z, and the remaining term is xy plus phi dash of x. Call that as equation number 6. Okay, using phi in equation number 4 now. So s is equal to minus y by x square into xt plus phi dash. Okay, that means using phi means here if you simplify this equation, f double dash is nothing but, if you cross multiply other side, I will get t into x. Substitute f double dash, that is in equation number 4, wherever f double dash is there, substitute that as equal to xt, and x get cancels, and transform this particular term to the left hand side, I will get s plus yt by phi dash. Okay, now substituting equation number 7 in equation number 6, so we'll get px plus qy plus z. So in place of phi double dash, substitute this value s plus yt by x. So simplify this equation, we'll get the final solution as px plus qy is equal to z plus xys plus y square t. Okay, moving to the next problem. Form the PDE by eliminating the arbitrary functions from z is equal to f of x plus ct plus g of x minus ct. Okay, now observe the given function there. Z is a function of x and t, they are given, so don't use the standard notations p, q, r, s, t. Okay, here z is not a function of x and y, z is a function of x and t. Okay, remember that one. So call the given equation as number 1. Differentiating partially with respect to x, will get dou z by dou x is equal to f dash plus g dash. A coefficient of x is 1 is there, so we won't get any multiplication. Remember, don't use dou z by dou x as p, since z is a function of x and t. Now differentiating one partially with respect to t, we'll get dou z by dou t is equal to f dash of x plus ct into c plus g dash of x minus ct into minus c. Okay, differentiation of f becomes f dash and ct becomes c, and here also minus c. Now differentiating 2 with respect to x, will get f double dash plus g double dash. Now differentiating equation number 2 partially with respect to t, I will get a mixed partial derivative dou square z by dou x dou t into f double dash of x plus ct into c, g double dash of x minus ct into minus c. Now equation number 3 partially with respect to t will get dou square z by dou t square, that is equal to f double dash of x plus ct into c, already c is there, it becomes c square, and g double dash of x minus ct into minus c square. Take here c square as a common factor and substitute equation number 4 in 6. Okay, in place of f double dash and g double dash is nothing but dou square z by dou x square. So all the constants, all the functions are eliminated. So this equation constitutes your final solution. Okay, moving to the next problem. So here also the given function is x into f of x plus ct, g into x plus t. Okay, don't use the again p and standard notations p, q or s t. Let it be, keep the derivatives dou z by dou x and dou z by dou t as it is. Call the given equation as number 1, partially differentiate with respect to x, apply the product rule for the first function, x into f dash plus f plus g dash will get it. Okay, differentiating 1 partially with respect to t, so x is a constant, f becomes f dash, g becomes g dash. Differentiating 2 partially with respect to x will get x, again apply the product rule for first function, x into f double dash plus second term f dash as it is, and differentiation of f becomes f dash, g becomes g dash. Simplify this equation, will get x into f double dash plus 2 times f dash plus g double dash. Okay, differentiate 2 partially with respect to t, will get a mixed partial derivative in the form x into f double dash plus f dash and g double dash. 3 partially with respect to t, will get dou square z by dou t square is equal to x into f double dash plus g double dash. Using equation number 6 in RHS of 4, that is in place of f double dash and g double dash, substitute that as dou square z by dou t square, that is x into f double dash plus g into double dash is dou square z by dou t square. In a similarly use 6 in the RHS of equation number 5 also, will get dou square z by, in place of x into f double dash plus g double dash, I am substituting the value dou square z by dou t square. Okay, and from 7 and 8 it will give the final solution, that is in place of f dash you substitute dou square z by dou t square. Final solution in the form dou square z by dou x square is equal to dou square z by dou t square plus 2 into dou square z by dou x dou t is the required PDE. Okay, so based on the questions discussed in this video, I given the 3 assignment questions. Work out all the problems carefully. Okay, so 3 questions similar to what we discussed earlier, that is second problem carefully work out since x square and t square is there, and in the third problem I is there just like a constant. You give the importance for eliminating f and g. Okay, in the next video we are going to discuss the another method of formation of PDE by eliminating the arbitrary functions. Thank you.